Hi guys, today we have a follow-up video. We didn't manage to finish the last video about the cheater holes, covered and uncovered. We just flew with covered cheater holes, and I wanted to show you the difference in sound. Underneath the duct tape, both sides, there is a special net to create turbulent flow of the air, to create jet sound. And I think it's quite amazing, but we'll see how you like it in the comments if you wish. And so the first flight we fly with cheater holes covered, so we have exact comparing of the sound with covered cheater holes and uncovered. So it's gonna be interesting. So we're flying 2 flights today, but also I want to show you 2 other super interesting things. First, I already painted the landing gear with silver paint and black paint, and it looks professional. So it looks like aluminium and it's normal PLA from my printer, 3D printer. The wheels are full PLA, not full, but like only PLA. This is just paint, not rubber. And the trouble in the last video with my wheel was not the wall thickness of the wheel, because I increased it just slightly, but I didn't use bearings, and PLA is getting soft with heat, with 50 degrees, and I just, because of the friction, I heated up the wheel and it just melted. So now every wheel has 2 bearings and a little pipe between them, so I can squeeze it with the screw. And these bearings are working perfectly. I flew already on them, and the landing gear is just perfect. So super nice, I'm super happy with that. And it's designed to be flush with the wing, so it's really nice. And I didn't have time to design this front leg yet, but I will. So the wheels are working, and PLA is super nice, and of course it's lighter. As I said in the last video, I'm saving 100 grams on these legs comparing to the aluminum ones. So super nice. And another surprise is in my pocket. Finally, the ESC, the huge ESC for the Odyssey arrived. This is 20S 300 amp ESC with burst to 400 amps. Of course, I'm not gonna fly so high, but and not 20S yet. I'm gonna use it on 16S and 260 amps. So we're gonna have 14 kilowatts at takeoff, which will give me probably around 16 kilograms of thrust, which is plenty for Odyssey, which weighs now 15 kilos. I'm trying to save some weight on other stuff, but this later. So it's beautiful, looks nice. It's programmed via a USB stick with the computer, and it weighs only 350 grams, which is not much for a strong ESC like this. I had good comments and good opinions about this ESC, so I'm really looking forward to it. And with the first look, it looks very solid. The heatsink is glued with the temperature, I guess temperature like transferring glue, the one that I'm using also, the white one. So, and it looks nice, it looks very nice. So I'm very pleased with this. And also there is a anti-spark plug, which I will use because I'm gonna fly on almost 60 or 70 volts. So a lot. Yeah, this is nice. But another interesting thing that I want to share with you, it's actually quite nice, is I'm flying, of course, on FrSky radio, FrSky system, receivers and sensors. And this is 100 amp 14S sensor, which actually works up to 16S. By the way, like everything in FrSky is built stronger than it's supposed to be. It's called FAS100S, and it's XT90 connector, and it also has 2 built-in temperature sensors, but it doesn't matter. But it limits me to 100 amps. Actually, it measures 126 amps, and then it stops measuring. The current flows, but it's inefficient, and also it doesn't measure the current flow. And I was thinking how to do it, to use it in Odyssey. So in previous flights in Odyssey, I used 2 of them in parallel, and my radio was computing and calculating, adding them together, and this gave me the 200 amp reading. But there is a simpler solution. It came to me a few days ago. I just took a normal wire, like the battery wire, the 12 AWG gauge wire, 12 gauge wire, or, yeah, I think I used 12 gauge wire, and I soldered it like a bridge between plus and plus with the plug, and here between minus and minus, because current, electricity, flows like water, so it always chooses less resistant path. And when I did it, it actually appeared that most of the current flows through the wire, not through the sensor. So now the sensor, actually I did it with the other one, it's already packed with the heat shrink. So now the sensor is not 100 amp, but like 400 amps, because, or 600 amps, because most of the current flows through the wire. And now only thing I have to do is to calibrate the ratio in my radio, which I can easily do. And with the clamp current sensor, measure exactly if it's correct. And I did it already, and it works perfect. So this way you can increase the capacity, or like the, I don't know, the measuring range of your sensor unbelievably. And it's super cool, because this sensor costs 35 euro, so it's super cheap. And now it's not a 14 or 16S 100 amp sensor, but 16S 300 amp sensor. I just will resolder these connectors and solder the bigger ones, like maybe 6 or 8 millimeter ones, and then thick cable between, and I can put everything through one sensor. It's even better, because if the sensor burns, like here, then you don't have a connection between battery and the motor and the ESC. And if you solder the wire, even if the sensor burns, you still have the connection with the wire. So it's unbelievable. It's super nice. I'm very excited. And of course, this is another FrSky sensor. You can also do it with the like an eye through sensor. Normally you put a wire through, and this sensor is up to 150 amps. So one cable you put through, and another cable exactly the same you put around. And if you solder it exactly the same, and the length of the cables is the same, and the type of cable is the same, then 50% of current goes here, approximately, and 50% of current goes through the sensor. So even if you don't have, like if you use different systems and you cannot calibrate your sensors in another radios, so if you use this kind of solution, you know that your sensor shows half of the current. So it's super cool. Okay, a lot of talking. Now we go back to the Black Horse Viper. We're flying again on 6 kilowatts at takeoff, so 2 batteries, 14S. And then it drops down to 5 kilowatts, and then in the end of the flight, 4 kilowatts. The plane flies nice. The level flight is almost 250 kilometers per hour, so it's cool. And we focus now on the sound. So first flight with cheater holes covered, and then second flight, cheater holes open. So I hope you enjoy it. Let's fly. I have to cool down the motor from time to time because we're on the edge. We have 450 gram motor for 60 and we're pulling around 5 kilowatts. And the ESC is also 100 amp 12S and we're pulling 110 amps on 14S. And it's a hot day today, so we have to remember it's really hot. Now super slow pass. Not really slow.
113 amps, 4,865 watts.
And we're half battery too, I guess.
4,613 milliamp hours.
Yeah, so more than half battery.
$5,309 milliamp hours.
This is an empty battery and it flies like crazy.
Milliamp hours. Gear down. Flaps full. 89 kilometers per hour. 97 kilometers per hour. 72 kilometers per hour. 6,075 milliamp hours. 85 kilometers per hour. 63 kilometers per hour.
I don't know if you saw this at the landing. We have exactly cross runway wind. It's not so easy. So the plane was flying sideways till the last moment of touchdown. It was kind of hard because I was approaching too fast. I was still about, I think, 80 or 70 kilometers per hour, and this plane can land at 35 because the wings are so huge. So I was going too fast, but I didn't want to go for the next lap. But it was cool with this cross side wind. It was exactly cross. It was really cool. I liked it, and the landing gear was working perfect. So super nice. I didn't say one important thing about the landing gear. I threaded the hole in the mechanics in the retracts. I threaded the hole with the 6mm thread, and also I threaded the hole in the PLA in the leg, and I didn't fix it with any screw, any lock nut, because it's always getting loose, and of course lock nut in plastic it's pointless. And I just put a few drops of CA glue on the thread into mechanics and on the thread into the PLA, and it works marvelous. it's locked forever. And if I want to remove it, if let's say the leg is broken, I just need to heat it up a little bit and then the CA glue lets go. So this is important tip, very interesting tip. Yeah, we flew without diving, few level flights, low passes, and the top speed with GPS we clocked
206 kilometers per hour.
26 kilometers per hour, which is nice. I didn't dive because when I was diving in the beginning, I was keeping half throttle to cool down the motor because we have a hot day today. And so level flight 200, 210, very nice. At takeoff we had 5,730 watts, 5.7 kilowatt, 127 amps on 14S, super nice. The flight was 7 minutes, almost 7 minutes, 6.5. So beautiful. Yeah, and that's it. And now the conclusion. We are removing the duct tape from the cheater holes, and we're gonna fly with cheater holes open, especially designed to create jet sound, and I hope it will be possible to hear this on the video. Okay, no more talking, let's fly. Okay, so now we are flying with cheater hose open. Let's see how it goes. I think it's faster. It looks faster. Okay, cooling down now for a bit. Definitely the sound is deeper.
122 amps. 47.6 amps. Amps.
I think the sound is unbelievable. I get the shivers. Ooh. Even at low speeds is nice.
32.1 amps.
Yeah, cooling down because I feel at the end of the fast passes that the motor is getting hot and is losing power.
Amps, 38.4 amps, 40 amps. 25.1 amps.
I just checked the ampere draw for cooling, to for sure the motor is cooled. 5,374 milliamp hours, 22.7 amps. Okay, last low pass after this cooling, and we have to land. I'm actually thinking to order a stronger motor for this plane. For 16S, 120 amps, and I will be able to push full throttle a little bit more. Milliamp hours. We have to land.
Gear down. $6,138 milliamp hours. Flaps full. 113 kilometers per hour. High rates 96 kilometers per hour. 73 kilometers per hour. 72 kilometers per hour. 67 kilometers per hour. Fast and flat. 6,100 milliamp hours.
So the flight was unbelievable. I loved it. Not only the flight was nice, but the sound is amazing. The difference is huge. I never did before. The same day cheater holes closed and open. And phew, the difference is huge. It's nice, and also plane is faster. The top speed was, with GPS,
260 kilometers per hour.
260 kilometers per hour. Unbelievable. This is 50 more than the previous flight. We dove a little bit deeper, for sure, because we dove from 200 meters, and the previous flight we were only 100 meters high, and now 200, but the difference should be marginal, maybe 20 kilometers per hour, and we are flying 50 kilometers per hour faster. It's nice. That means that the EDF is suffocating, doesn't get enough air, but also the turbulent air, it's good for the EDF, for the drive. So I'm very pleased. I'm super, super pleased. The sound is great. I hope you liked it. Please leave some comments below, and some data from the flight. 6 kilowatts at takeoff, 128 amps, full battery of course, and then it was 120 amps, 5 kilowatts and something in the middle of the flight, so nice. 6 minutes, almost 7 minutes flight. And I've put my hand inside from behind into the thrust tube to touch the motor just after landing, and the motor is not hot. It means that I can push harder, and I will install the temperature sensor on the motor and on the ESC, and we will know exactly what is the temperature, and maybe I'll be able to go full throttle takeoff till landing. So I hope it will be possible, and this means that maybe then the third battery will go in and the flights will be way more exciting. Okay, it's enough for now. Thank you so much, and I hope to see you next time.